Let's think about how to compute the value of this limit. The first thing we can do is just try to plug in x equals 1 and see what happens. In the numerator, we get square root of 1 plus 3 minus 2, which reduces to 2 minus 2, or 0. In the denominator, we get 1 minus 1, which is also 0. This means that the limit is of type 0 over 0, which is an indeterminate form. As we've seen in other videos, this means that we need to do a little bit more algebra before we can compute the value of the limit. Because of the square root, the first thing we need to do is rationalize the numerator. This means that we need to multiply the numerator by its conjugate, which in this case is square root of x plus 3 plus 2. We also need to multiply the denominator by the same expression so that we're essentially just multiplying by 1. In the denominator, we want to keep these two terms separate, the x minus 1 and the square root of x plus 3 plus 2. In the numerator, we can make use of the symmetry between those two terms to determine that the numerator becomes x plus 3 minus 4. Let's take a closer look at this step. When we multiply an expression by its conjugate, we get some nice cancellation. To see this, let's distribute the terms. First, we multiply the two square root of x plus 3 terms. Next, we multiply the first square root of x plus 3 by the plus 2 in the second factor. Then, we multiply the negative 2 by the square root of x plus 3 in the second factor. And finally, we multiply the negative 2 and the positive 2 to obtain negative 4. The 2 square root of x plus 3 term and the negative 2 square root of x plus 3 term cancel, and the two square roots at the start combine to give us x plus 3. This is how we reach the expression x plus 3 minus 4 that we saw earlier. Let's take a moment to remind ourselves why the square roots combine in this way. There are two ways to think about this. One way is to remember that the square root is precisely the quantity that has this property. So in other words, by definition, the square root of x plus 3 times the square root of x plus 3 is equal to x plus 3. The way that we usually see this expressed is that when you square a square root, you get the quantity inside. So in our case, we have square root of x plus 3 times square root of x plus 3, or in other words, square root of x plus 3 squared, and by definition, that is equal to x plus 3. There's a second way to think about this simplification that's a little bit more generalizable, and that's to think about it in terms of exponents. So here we want to remember that square root of x plus 3 is the same as x plus 3 raised to the 1/2. So we have two terms like that multiplied together. We can now use our exponent rules to combine the exponents, remembering that when we multiply two things with the same base, we add the exponents, so our new exponent is 1/2 plus 1/2. So in other words, we have x plus 3 raised to the first power, or just x plus 3. And again, this is a more generalizable method. So for example, if you have an expression involving cube roots or fourth roots or something like that, you can simplify it by converting two exponents. But when the expression that you're trying to simplify involves only square roots and not cube roots or fourth roots or anything like that, it's easiest to just use this defining property of square roots. So for example, square root of 5x plus 3 times the square root of 5x plus 3 is just equal to 5x plus 3. And again, that's the quickest way to simplify expressions involving square roots. So now we can return to the expression we had before. The numerator simplifies to x minus 1, and we see that we now have a common factor of x minus 1 in the numerator and the denominator. Cancelling this common factor leaves us with 1 over the square root of x plus 3 plus 2, which is now defined at 1. So we can now plug in x equals 1 to give us 1 over the square root of 4 plus 2, which reduces to 1/4, and that's the value of our limit.